Bum 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 bum.
Tomatoes?
Hello, welcome to the video for what is get actor array average location. Okay, besides the mouthful, this is basically a node, and if we go and find the node right here, which is going to take in an array of actors, and it's going to return back a vector value, which is the location. And that location is going to be basically the average location, or for the most part, you can think of it as the center of where those actors are inside of our world. Let me go and show you this. These three actors are what I'm going to be targeting, and I hit play. This is my actor's average location for all three of those. So it's going to be roughly somewhere around, I don't know, here or so. And it takes into effect the X, the Y, and the Z. You're basically adding these three values together and dividing by 3. That's what you're going to get back as your result. And let me go and show you that. Let's take our boxes and let's zero out their location. And you'll notice, well, our average location is 0 because, well, they are all at 0. We'll take one of them. We'll move it up 90 in the Z. So you see it moved up. Let's move it up 180. Now you can see it's completely separate. And you'll notice our average location is X0, Y0, and Z60. Now keep in mind, it's an average. It's technically not the center. That's why I said you could think of it as the center. It only really is the center if you have items of different locations. We have 3 items here. 2 of them at all 0, and 1 of them at 180. So the only change is going to be a Z value of 180. Now you'd think the middle point of that would be 90. However, again, it's just simple math. We add up 0, 0, 0, 0, 0, 0, and 0, 0, 180, and divide them all by 3. So 0 divided by 3 is 0, 0 divided by 3 is 0, and 180 divided by 3 is 60. So while it's useful to find sort of the center, it's only going to be really nice if you have things in completely different locations. So if we were to, for example, let me reset this back to... Actually, you know what? Let's move all of these up to 180. Now you notice our average is 0, 0, 180. And let's go ahead and just move each of these out in a different direction. So we'll go 100 on the X. We'll go negative 100 on the X. And then we'll move this one out 100 on the Y. And now you'll notice our average location is going to be X of 0. Because we've basically have a positive and a negative and then a 0. And they're canceling each other out. We have only one single value on the Y of 100, so that's going to end up being 100 divided by 3 is 33, and they all contain 180 for the Z, so it's going to be 180 plus times 3 divided by 3. It's going to nullify each other out. So our average location is going to be roughly, according to this, in the middle here and over here a little bit on the Y. So that's going to pretty much wrap up our actor array average location node. Takes in an array of actors. In my case, I simply got all of my boxes and stored it into an array. And it outputs a vector, which is basically add all these up, divide them by the count, return back the value. And it's useful if you want to find the average location of something. So for example, let's say your player fired 10 bullets at a target. And you want to see where their average hit is. The average is nice because that individual single value really isn't going to throw things too off. So let's say they put 5 values in the center and 1 shot off in like the outer ring. Since you're using not the center location, which would be near the middle rings, but the average, because you have more hits in the middle, your average is just going to be slightly off of the middle because that one value only throws it off. So that's it. That is our get actor array average location node.